Hello everyone, in this video we'll be discussing about regular grammars. Different ways to describe the class of regular languages are finite state machine, regular expressions, regular grammars. Regular grammar, sometimes also called right linear grammar, and about right linear grammar or regular grammar you will see in the next slides. What's the definition of a regular grammar? A regular grammar G is a quadruple. There are four tuples. Those are V, sigma, R, S, where V is the rule alphabet and which contains non-terminals. That is, the symbols that are used in the grammar but that do not appear in the strings in the languages, and terminals can appear in the strings generated by G. So always remember that terminal characters are the part of the string, whereas non-terminal, it is just to specify the it's a alphabet or a symbol just to specify the rule. Next we have a sigma. Sigma is nothing but a set of terminal, or you can tell it as a alphabet also. And the sigma is the set of terminals is a subset of V. V contains non-terminals and terminals. Then R is a finite set of rules of the form X gives Y. And remember, X should be always a non-terminal. S is the star symbol and which has to be a non-terminal. Next, the format of rules. What's the format of rule? In a regular grammar, all rules in a R must be, that is, whenever you to say grammar is nothing but set of rules. There are many rules in that. Each rule can take the form of can have left hand side and right hand side, and left hand side and right hand side are separated by a arrow mark, and left hand side, that is a single non-terminal, and right hand side, that is epsilon or single terminal followed by a single non-terminal. That means a single terminal can come the left of the single non-terminal in the RHS. So these are the example. S gives A is a terminal. How do I say this is a terminal? This always can be a part of the string. S gives epsilon. This can be one rule. This can be another rule, and T gives AS. You can see that terminal followed by a single non-terminal. These are all legal rules in a regular grammar. When it comes to S gives ASA, this is not a regular grammar, because as there is an alphabet followed by non-terminal and followed by a terminal, it's not allowed. ASA gives T. This is also not a non-terminal. This is also not a proper rule. Regular grammar examples. To recognize A. How do I write? Before moving on to write a regular grammar to recognize A star, I will first tell how to recognize A. A is just a character, single character. How do I write? You have to start with one start state. Start state is the starting non-terminal. Let me represent starting non-terminal as S, and that gives A. So this grammar will recognize A. Next, to recognize any number of A's. What do you mean by any number of A's? This can be written something like this. Any number of A's. So this itself is your start state. So how do I write that? The regular expression, you know that it is a star. Regular expression is A star. Now here, to get many A's, and remember, when I say recognize any number of A's including epsilon, so since the language contains epsilon, the start has to give epsilon. Start has to give epsilon. Directly we should get epsilon. And then any number of A's, how do I get? A should be keep on repeating. That is, you should call itself again and again. And one point of time, this gives S can vanish by substituting epsilon. So let me explain how do I get that. Let me tell you the derivation, how I can get 4 A's or 5 A's. So for example, if I have to recognize A, then how do I make use of this? Start from the start state. For the first A, obviously the rule that can get me A is, single A is this AS. Yes. Then I have again S here, isn't it? So this will be as it is. How can I get another A? Again substituting the right hand side of S. That is again A, yes. Now how do I get a third A? Again substituting S by AS. How do I get the next A? Again substituting AS. And how do now I've already got that my aim was to get 4 A's. I've already got a 4 A's. Now this should vanish. What I should do, I can substitute epsilon. So if I substitute, I can get A. This is called as derivation. Okay, this is called as a derivation. Now to recognize the strings of A's and B's including epsilon. So if I want to write a regular expression for this language, it would be A union B whole star. Now how to write a grammar? Grammar, yes, gives. You have to start from some, because the strings can be, language can contain a string, that is epsilon. Language can contain epsilon, then AB, AA, BA, it can be of this form, BB, ABA, and many. Okay, so starting, since I have told it is, since the language contains epsilon, one thing is clear, that start state should give immediately epsilon. Okay, start state can give epsilon. Next, since the starting character, either it can be A or it can be B. So start can directly give start from A, and then start can give B. But it can be again, it can call the same thing itself. It can be yes, because it can be a combination of AB. So how do I get that? S can give AS, S can give BS. So this is the grammar for to recognize strings of A's and B's including epsilon. AS. So that this thing I can write like this. S can give you AS, BS and epsilon. Next, to recognize just 2A. How do I get that? Because 2 A's must be there. For the first A, I will use one terminal, non-terminal. Non-terminal cannot be a part of the string, remember. So again, T is what? It should recognize another terminal A, that is second character. So if so, you can stop it. So S can give you AT, T can give you another A. So this is the rule. So grammar will contain this rule. And then how to recognize AA star? There has to be 2A or epsilon and then 4 a's and so on. How do I get that? So that's why, since I told A star means language will contain epsilon, epsilon, then A, and so on. So do I get that? Minimum, first of all, S can give you epsilon. So do I get 2A, T and T gives A. But again, this 2A's multiple of that is multiple of 2A's need to be repeated. How? Again, I should call back S. So T can give you AS. Now, and remember, for all the rule or grammar, whatever you write, you need to write a quadruple. How to write a quadruple? Quadruple G is represented as V. V is nothing but a set of terminals and non-terminals, S comma A. Sigma, sigma is only alphabet. R, R is the rule. So you can specify this as a rule. So rule equal to S gives A. Then yes, starting symbol is yes. It's like a start state. Okay. So let me write for this quadruple. G equal to, so this is nothing but a set of rules. So I will write this as R equal to and then this. So G equal to V. V is nothing but set of non-terminals and terminals. So S comma T, A comma A, that's it. Epsilon is cannot be a non-terminal. Okay. Then STA. After that, sigma. Sigma is just a B. Then V. This is V variables. This is sigma. Then we have R. R is nothing but I've represented. And then S. S is the start state. What's the start state in this? Yes. So similarly, you can write a quadruple for all other grammars. Next, I am going to write a regular grammar for the language L equal to set of all strings of at most 2. At most 2. What's the meaning of that? Minimum is 0. So at most 2. And where the alphabet is A comma B. So it can be epsilon. It can, so language can contain epsilon, A comma B, AB, BA, BB. How do I get that? First of all, the starting state, let me start with A. A is epsilon. A can give you epsilon. Then A can start from A because there has to be maximum 2 characters. A can start from A and go to the next character. And A can also start from B because starting character can also be B. So either A or B. So next it can go to T. T can give you the next. Okay. So T can give you the next character again A, and T can give you B, and you know that this T that is you can even recognize single A. How do I recognize single A? Single A I can recognize by, if I start from the start state, A can give you AT and T should vanish. T should vanish in the sense T can become epsilon. So you can give a rule T gives epsilon, that makes that allows you to identify a single character A also or B also. Okay. So this is about the regular grammar for the language L equal to set of all strings of at most 2. So the regular expression would be epsilon union A union B, epsilon union A union B. So this is the regular expression, whereas this is the rule. Now if you have written the rule, then we can write the quadruple. How to write the quadruple? G equal to V. V is nothing but all the variables A, T, A, comma B. All the variables are nothing but non-terminals and terminals. Sigma is A comma B. then R is this. We have written here all the rules of the grammar. Next, S is start symbol. What is the starting symbol in this case? It's A. So which non-terminal is going to start? That is A in this case. So this is about the quadruple. Next we'll write grammar, regular grammar for W belongs to, that is W is nothing but strings belongs to A comma B star, such that W ends with a pattern A. Now before this the regular expression is of the form A union B whole star A. What is must in this case? A is must. Let me tell you how to identify 4A's. 4A's means it is must, isn't it? So yes, if I start first A, then I have one more A, then I have one more A, and then finally you should end with the fourth A. Did I get that? If I go to this, so S gives 8. I can't write S gives AS. That can give you many A's. So every A you should use one more new non-terminal. T gives A, B gives C, C gives C. This will give 4 A's. This will give 4 A's. So what is must? At least this 4 A's must, isn't it? There may be A's or B's before this 4 A's. So how do I write that? There may be 4 A's and B's before this 4 A's. So that how to write. So that's why it can be as usual. S gives AS, S gives PS. So we have written. So here I have used a different non-terminal, and you can use this instead of T. I have used here A. Okay. This is about the rule. So R is nothing but this. So we can write the quadruple G equal to V comma sigma comma R comma S. So what is V? S A comma B. So all the variables, non-terminals and terminals. Then sigma is nothing but A comma B. R we know that all these set of rules that makes a grammar. All the set of rules that makes grammar. Next, yes, starting symbol is starting non-terminal is yes. So this is about the regular grammar. Next, we'll have one more regular grammar to write. That is, write a regular grammar for the language starting with the set of all strings of starting with the A, set of all strings starting with the A and ending with B. So in between it can be anything, and the alphabet it is going to contain is A and B. Alphabet it is going to contain is A and B. So set of all strings of starting with A and ending with B. Now the regular expression is in this format. There has to be the strings has to start with A, end with B. In between it can be combinations of A and B. It can be any number of A and B. So that's why it is A union B star. Now how to write? What is must here? The starting has to be A. So in between it can be anything. You know that how to write for A union B star. So it can be yes gives something like A gives A, B gives BB. So from here, after getting this, you can directly go to this also. That means this portion is optional. Remember that this portion is optional. So we can write S gives AT, T is nothing but AT or BT, in between portion, and T can, if I don't, if the string does not have this portion, only AB also fine. That's why S gives AT, T can give B also. So in between, this T can take AT and BT. So this is about the rule. Now the quadruple. What is quadruple? G is nothing but B sigma R comma S. So I will write that R equal to this, whereas quadruple G is nothing but S comma T comma A comma B sigma. It is sigma, sigma is A comma B, what is R, and then S. So this is about the regular grammar and regular grammar examples.